Methods of creating service-oriented software systems. The object of research is service-oriented architectures and ontological models. The aim of the work is to create a formalism for describing the interaction of services and algorithms for building web service interfaces with effective SOA system using a paradigm based on different ontologies of data access and query transformation. To achieve the goal of work, the following tasks must be solved. Carry out analysis of basic types of cooperation structures of SOA services. Develop algorithms of description and analysis of conceptual model of SOA system oriented on ontological approach, which allows to adequately describe interaction of web services. Design algorithms of automated construction of interfaces of web services for SOA architecture, which allows to build interfaces of web services based on ontology. Develop the software implementation of a SOA system which uses received algorithms of automated construction of interfaces of interaction of web services. The growing popularity of technologies such as cloud computing, distributed systems, and semantic web in recent years on the Internet shows the relevance of the task of organizing interaction of Internet resources among themselves. Service-oriented architecture provides such interaction of software development. To implement the SOA system, it is necessary to create a formalism for describing system process by ontology and effective algorithms, or to improve existing ontology-based data access algorithms. The central concept of SOA architecture is service. The name service is defined in the dictionaries as a performance of functions for each other. When developing a system for Internet, the main object of the SOA concept is the web service, a web address program system that can be identified by a web address, which is equipped with database. There are many implementations of SOA architecture. Currently, most software solutions developed in accordance with service-oriented architecture often use a complex protocol SOAP, or a simple object access protocol. It is a protocol for exchanging structured information in a distribution computing environment for the implementation of web service and computer networks. It uses web service description language, which is like XML language specification, which is intended to create documents that describe web services in detail and how they are accessed. When we talk about service-oriented systems, we should consider Semantic Web, which is a promising industry in the field of Internet development. The main task of Semantic Web is to present information in a form suitable for machine processing. The main tools of Semantic Web are semantic networks, universal resource identifiers, and ontology. When we build ontological model of SOA system, it is necessary to consider active work of SOA architecture with databases and possibility of using database for processing larger volumes of data. This system can be built using OBDA technology. This approach uses the advantages of a domain language to work with ontology with metadata queries to the database. The basic principle of OBDA systems operation is to transform the queries to the knowledge base into corresponding requests of the database. Databases in OBDA technology are a structure of a box of descriptive logic. Convenience and simplicity of extension of SOA system with an increase in the number of elements of a service-oriented system. It is not necessary to expand algorithms by new structures. It is necessary only to expand ontology by necessary axioms and statements. It is also necessary to develop algorithms for realization of correspondence because such algorithms based on descriptive logic at this time do not exist. At the same time, structured algorithms, as shown before, do not have the advantage of domain language technologies. It It is necessary to reduce the number of generated requests compared to other algorithms of logical conclusion. Unlike standard algorithms of logical conclusion, there is a possibility to create a query algorithm to a database optimized for a SOA task. This algorithm will differ from other algorithms by a smaller size of generated queries to the database. Based on this concept, we developed an SIR system. This system provides a convenient interface between web service based on ontology and viewing of existing web service interfaces. This system consists of several modules: interaction module, calculation module, a test ontology, interface of interaction, and cluster of web resources. We have tested this system using some query transforming algorithms. The algorithms were evaluated on the previously described test ontologies. The test results showed that the execution of SIR algorithms requires a small amount of CPU time and RAM. The developed software can be used as a basis for systems of automatic construction of interfaces of interaction of web services. The ontology structure requires for the system to work as a markup of the Semantic Web standard. This indicator allows the system to move to a semantic service-oriented architecture based on Semantic Web services. In conclusion, the SOA system is developed using a paradigm based on the ontology of data access. To implement the SOA system, an algorithm was created for describing the processes of the system with the help of ontology, creative effective algorithms, and approved existing OBDA algorithms working with SOA systems. Developed algorithms for description and analysis of conceptual model of SOA system oriented on ontological approach, which allows to describe interaction of web services. Developed algorithms of automated construction of interfaces of web services and CRUD algorithms for SOA architecture, which provide an opportunity of automatic creation of interfaces of web services. Algorithms differ from the same speed of construction and the general model. The new query transformation algorithm for the SOA system differs from the more general algorithms of query transformation by speed of work due to ignoring the non-important elements of input data. The difference in speed between the received algorithm and analogs depends on the number of non-important elements in ontology.